Let us see multiple choice questions from topic F block elements. Friends, you know that periodic table divides into four blocks, that is S block, P block, D block and F block. So here at the bottom of the periodic table, F block elements are present. It consists of two series, lanthanide, this one is lanthanide series and actinide series. Friends, you know position of lanthanide series in periodic table is in sixth period. So here I see this one. Here lanthanides are present, that is in sixth period and in third group. This group number is third. Third group, it is also known as third B. And that of actinide series is in seventh period. This one is actinide series, that is it is seventh period and it is also in third group, that is third B. So let us start questions from F block elements. First question, F block elements are called dot dot elements. Transition, inner transition, normal, none of these. So F block elements are known as inner transition elements. F block elements consist of dot dot series 5, 6, 2, 4. So F block elements consist of two series, that is which one? Lanthanide series and actinide series. The general electronic configuration of F block elements is options, different options are given. So from that, correct option number B, that is n minus 2 F 1 to 14, n minus 1 D 0 to 1 ns 2. This one is the general electronic configuration of F block elements. The lanthanones and actinones are collectively known as, options are D block elements, F block elements, inner transition elements, either B or C. We well known that the lanthanones and actinones are collectively known as F block elements as well as inner transition elements. So correct option is D. Yttrium earths were discovered by, options are Berzelius, Gadolin, Oswald, Klaproth. So correct option is option B, that is Gadolin discovered the yttrium earths in 1794. Cerium earths were discovered independently by, options are Berzelius and Gadolin, Klaproth and Gadolin, Klaproth and Berzelius. So correct option is D, Klaproth and Berzelius. In 1803, Klaproth and Berzelius discovered cerium earths. Important mineral of lanthanides easily available in India is cerite, gadolinite, monazite, bastane. So correct option is C, monazite. Dot dot mineral is the main source of rare earths along with thorium and uranium in India. So here also correct option B, that is monazite. Monazite mineral is the main source of rare earths along with thorium and uranium in India. Lanthanides having odd atomic numbers are plentiful than those having even atomic numbers. Options are more, less, odd, even. Correct option is B. Less plentiful than those having even atomic numbers. Means odd atomic numbers are less than the even atomic numbers. Among lanthanons, element do not occur in nature. Samarium, praseodymium, thulium, neodymium. So correct option is B. Promethium. The next, lanthanides having incomplete outer shells. 1, 2, 3, 4. So lanthanides having how many incomplete outer shells? That is 3. The general electronic configuration of lanthanides is. So correct option is option A, that is xenon core, 4f 1 to 14, 5d1, 6s2. Lanthanides are also known as F block elements as electrons are added in subshell. So we know that we see the general electronic configuration. So we know that added electrons are added in 4f subshells. So correct option is B. In lanthanide series, the differentiating electrons are added in which one? 4f subshell. Lutetium 3 plus has electronic configuration. So lutetium is the last electron from lanthanide series. So having electronic configuration xenon core, 4f14, 5d0, 6s0. The common oxidation state shown by all lanthanides is 1 plus, 2 plus, 3 plus, 4 plus. So common oxidation shown by all lanthanides is 3 plus. Anomalous oxidation states of lanthanides are. So anomalous oxidation states shown by lanthanide is 2 plus and 4 plus. Europium and ytterbium in 2 plus oxidation state acquire the configuration. Options are 4f0 and 4f7, 4f7 and 4f14, 4f0 and 4f14, 5f0 and 5f7. So correct option is option B, to acquire half-filled and full-filled electronic configuration. Europium and ytterbium in +2 oxidation state shows 4f7 and 4f14 electronic configuration. In lanthanides, there is in atomic and ionic radius with increasing atomic number. Increases, decreases, remains same, none of these. So in lanthanide, there is decrease in atomic number, atomic and ionic radius with increase in atomic number. The atomic radius of lanthanide decreases by picometer even though nuclear charge increased by 14 units. So correct option is option A, that is only 9 picometer. Cause of lanthanide contraction is poor shielding of 4f electrons, gradually increase in nuclear charge from La to Lu, both A and B, none of these. So correct option is option C, that is both A and B, means poor shielding of 4f electrons and gradual increase in nuclear charge from lanthanum to lutetium. Basic character of hydroxides of lanthanides ... from lanthanum to lutetium. Increases, decreases, remains same, none of these. So it having correct option B, that is decreases. Basic character of hydroxides of lanthanides decreases from lanthanum to lutetium. Due to lanthanide contraction ... LuOH thrice shows less basic character. RH, IR, AgAU pairs shows similar properties, that is rhodium, iridium, silver, gold pair shows similar properties. Lanthanide shows similar properties, and D, all of these. So correct option is option D, all of these. Covalent character of metal hydroxide bond MOH bond ... from LaOH, that is lanthanum hydroxide, to LuOH, that is lutetium hydroxide. Increases, decreases, remain same, none of these. So it having correct option A. Covalent character of MOH bond increases from LaOH to LuOH. This is according to Pajan's rule. Due to lanthanide contraction, LaOH thrice becomes ... basic. Least basic, most basic, small basic, none of these. In last MCQ we see that basicity decreases, therefore LaOH thrice is most basic. Modern method for the separation of lanthanides is fractional precipitation, complex formation, fractional thermal decomposition, ion exchange. So modern method for the separation of lanthanide is ion exchange. Basicity of lanthanide ions ... from La3+ to Lu3+. Increases, decreases, remains same, none of this. So we know that basicity of lanthanide ion decreases. Option B. ... ion is eluted first, followed by the remaining lanthanides Lu3+, Ln3+, La3+, Lr. So correct option is option A. Lu3+ ion is eluted first, followed by the remaining lanthanides. In aqueous solution, stability of lanthanide complexes ... from lanthanum to lutetium decreases, increases, remains same, none of these. So correct option is increases. In aqueous solution, stability of lanthanide complexes increases from lanthanum to lutetium. In ion exchange method for separation of lanthanones, ... ions are held most strongly on resin. Largest, smallest, least basic, medium. So here correct option A, that is largest ions are held most strongly on resin. In the separation of lanthanones by ion exchange method, complexing agent used is. So in ion exchange method, which complexing agent is used? So here correct option is option A, that is citric acid and ammonium citrate. Separation of lanthanones by ion exchange method is more rapid and efficient at pH about. So at which pH separation is rapid and efficient? That is option C, at 3.5. Actinides are also called ... elements. 5f block, second inner transition, both A and B, none of these. So correct option is option C, that is both A and B. Means actinides are called 5f block elements as well as second inner transition elements, and lanthanides are known as the 4f block elements as well as first inner transition elements. Next, commonly the successive electrons get added in dot dot orbital in actinides. Correct option C, n-2f orbital. The successive electrons get added in n-2f orbital in actinides. Dot dot is mostly obtained from monazite, protactinium, thorium, californium, neptunium. So correct option is thorium. Thorium is mostly obtained from monazite in India. Okay. The elements after uranium are called dot dot elements. Lanthanides, transition, transuranic elements, none of these. Correct option C. The elements after uranium are called transuranic elements. Transuranic elements are also called dot dot elements. Lanthanides, lanthanones, D block, man-made. So transuranic elements are also called man-made or synthetic elements. Man-made or synthetic element. Then actinides are placed in dot dot period and dot dot group in periodic table. So in starting of this video we see that actinides are placed in which period? 7th period and 3rd group in periodic table. You also may ask that 3rd B or 3rd A. Remember that 3rd B. It also written as 3rd B. Actinones have dot dot incomplete outermost shells. 2, 3, 4, 5. So actinones have 3 incomplete outermost shells. The common oxidation state shown by all actinides is 3+. The general electronic configuration of actinides is. So general electronic configuration, correct option is option A, radon core 5f1 to 14, 6d0 to 1, 7s2. The electronic configuration of uranium is. Last question we see the general electronic configuration. According to him, uranium having how many atomic number? 92. So radon core, we all know that radon having how many atomic number? 86. So correct option is D, radon core 5f3, 6d1, 7s2. The electronic configuration of curium is. So curium having atomic number 96. So correct option is option D, radon core 5f7, 6d1, 7s2. It acquired half-filled electronic configuration, half-filled stability electronic configuration. Okay. Dot dot is the most suitable method for preparation of transuranic elements. Heavy ion bombardment, neutron bombardment followed by beta decay, accelerated projectile bombardment, all of these. So correct option is A. The heavy ion bombardment is the most suitable method for preparation of transuranic elements. To overcome repulsion barrier of target nucleus, energy of projectile is increased by increasing its velocity by cyclotron, synchrocyclotron, HILAC, all of these. So correct option is D, that is all of these. Here some reactions are given. So in first reaction, uranium 92-233 plus He24, that is alpha particle, it emits four neutron and plus 4 neutron. So how we find that which elements is present in that place? So here 92 plus 2, that is 94. So in three options 94 atomic number are present. Only D not contain 94, therefore D eliminate. Then we check the mass number. So here 233 plus 4 means 237. At product side, there is removal of how many neutron? 4 neutron. 1 neutron contains 1 mass number. Therefore, 237 minus 4 is equal to 233. So, option B having mass number 233. So, correct option is B, that is plutonium 94-233. Then next question, plutonium 94-239 plus it gives curium 96-242 plus 1 neutron. So here also we balance the atomic number and a mass number from left side and right side of reaction. So here 96 plus 0, here 94. So for balancing we required atomic number 2. So from that we confirm that option B. So atomic number 2. So atomic number 2 having which element? Helium. Which also check the mass number 242 plus 1, that is 243 minus 239, it gives 4, that is 4, option B. In next reaction, curium 96-244 plus it gives nobelium plus 6 neutron. So here we also balancing. So 102 minus 96, 6. So the atom having atomic number 6 is carbon. But in option there are two options having carbon 613 and carbon 614. So here we also check the mass number. So 244 plus in right side 251 plus 6, that is 251 plus 6, 257 minus 244, that is 13. Means option A is correct, that is carbon 6, 13. The IUPAC name of the elements having atomic number 150 each. So long form of IUPAC is International Union of Pure and Applied Chemistry. So according to that nomenclature, this nomenclature giving some rules for the elements having atomic number greater than 100, that is super heavy elements with atomic number greater than 100. So according to that nomenclature, if you remember roots of the number, then you can easily identify the nomenclature. So for 0 they gave nil, 1 un, 2 bi, 3 tri, 4 quad, 5 pent, 6 hex, 7 sept, 8 oct, and 9 in. So here question asked IUPAC name of the element having atomic number 150. So for 150, for 1 un 5 paint, paint, for 0 it is nil, and ending is done by the IUM, unpaint, nilium. So correct option is option A, unpaint nilium. Then next, the symbol of the elements having atomic number 119. So for 1 we know that un u, another one small u, and for 9 in UUE, that is option C. This one is last question. The symbol of the element having atomic number 119 is UUE. So here we completed the 50 questions from the topic A block elements. So please subscribe, like and share my videos to your friends. Thanks for watching these videos. And for bioinorganic chemistry, iron and steel, and nuclear chemistry, you also see my videos on that channel. Link for these videos are given in the description box. Thank you.